Alright, welcome back. So today we're gonna do shotgun and we're gonna do movement control fixing. So the first things first, when we were moving around we didn't have the object pointing to where we're looking at. So what we're gonna do is we're gonna make the guy face where we're looking at. So we go into our physics controller, and over here we're gonna write a few things. So first we're gonna do a void auto rotate. Now the reason why it's called auto rotate is because it's gonna automatically rotate the dude once we get him, and just gonna call him into our function. So now it's connected, and what we're gonna do for the auto rotate is we're actually gonna do a simple vector3. We're gonna get a camera view, and we're going to get a player view. So where the player is looking at and where the camera is looking at, and then we're going to find the angle of difference, and then we're going to make him rotate so he gets to that angle. So we're going to do a camera view equals to game.player.get world and direction, and we're going to choose the direction he's looking at. By default he's looking at the negative z-axis, which is our forward, which is basically the bottom, but because the camera's angled, that's going to be our forward, so we don't touch that. Player view is going to be the node itself, the get world direction, and if we look here, our physics controller is facing the main thing, so we're just going to be looking at the forward, which is our positive y, right? Because our forward is the positive y, so we're going to say get direction, and it's going to ask for the direction. We're going to choose y. So now we're going to see where the camera is looking at, where the player is looking at. Then we're going to store that in the angle, a float angle, and we're going to say something like mathlib.angle. So they have a function which takes 3 vectors, and it spits out the angle difference. The first vector being the in, the out, or the first and second. So we're going to choose the camera view and then the player view. So it's going to choose the difference. And then the third one is the up direction. This is the direction which is the looking up, which we delete, so we only take the vector differences from two-dimensional vectors. So we're going to do get world direction, and we're going to choose the z direction, which is our top. We could also choose nz by default, but whatever, it's all the same thing. So now that the angle's checked, we're going to take the main character, and we're going to add an angular impulse, and we're going to just add it from the top. Because the impulse is added from the top, it's rotating left and right, and we're going to multiply it by the angle. So if there's no angle, there's no rotation. If there is an angle, there's a rotation. Now with this fixed, we cannot use angular impulse on our movement anymore. So now we're going to move like a chess piece, up, down, left, right. We're going to change this to x, I believe, because we're moving right, and this is going to be nx. Alright, we're going to remove the game IFPS because that's just going to slow the dude down really fast. And that should be it for our rotation. So that's done. The next thing we're going to do is go in here. In aiming, we're going to go into the shoot shotgun. And we're just going to do some stuff. And once we click the left button, then we shoot. So the stuff we're going to do is actually show you the difference, or how we're going to do it. So we're going to do it through something called a Frustum. Frustum is basically a pyramid that has been cut. This is where our bullet hole is going to be, and that's going to be our spread. So we're going to use this lazy method. It works, and it's not super accurate, but it's good enough for now. So we're going to use this Frustum. And how we're going to do that is actually we're going to use material 4. We're going to call it Frustum, and we're going to use one of the math library functions. I believe it's called perspective. And now if you look through a camera, you'll notice we have FOV, aspect, and an F. So FOV is field of view. I'm just going to choose 40. The aspect ratio, I'm going to choose it as 1.5 float. Near is how close it's supposed to be, so I'm going to say really close, and for far, I'm gonna say it only goes like 4 meters. So that's the size of our frustum, our basically trapezoid pyramid. So that's there. Now the next thing we're gonna do is actually tell it how to face, because now we have the thing, and in Unigine it defaults to looking downwards. If you've ever seen a frustum, normally it defaults to looking downwards, so like it's sitting on its bigger piece. So what we're gonna do is we're gonna get the node.getWorldRotation. Okay, now that's good, but the thing is it's still facing down, so we're going to multiply by a quaternion or by a rotation, which will make it that we're facing it away. And what we're going to do is we're going to use 90, 0, 0, so it's going to be rotating on the x-axis, so across it by 90 degrees. So if we were to just literally rotate this on the x by 90 degrees, let me just say 90 degrees, it's going to be now facing. So if you were to imagine like the smaller head is here and the bigger head is on the bottom, and you were to rotate 90 degrees, now the bigger head is facing where we want it to face, and then the smaller head's facing away. Okay, so that works that. Then this tells you, this also adds where the dude is facing. So if the dude's facing that way, the thing should rotate around there, and then it should be facing that way. So enough talking of that, let's actually write this. So material for, now we need something called a view model. So we're just gonna write view, and it's gonna be new material for. We're going to give it the quaternion rotation, because it's going to ask for rotation, and it's going to ask for the position where we want it. So we're going to do gun get child, because we want the trigger point, and then get position, the world position. Alright, so with this material for, now it's asking for the rotation of where it's supposed to be facing and everything, and now it's also asking for the position, the world position. Okay, so now that's all connected. Now how do we actually do this? Let's just visualize it so you can see the frustum. So projection and the transformation. So the frustum is the projection, how big it's going to be, and transformation is where it's going to be. So that's the view. And then vector 4 dot black. Okay, and we can play it right now. So now that we have it, as you can see, that one's just whatever, but the black square now shows how big the spread is and how strong or how far the bullet goes. So it goes wide, it goes far, and then you can also see I'm just moving my camera and the dude is moving correctly. Now this also gave us the left and right. We didn't have an animation to it, so we can add that later on. But anyways, so we got that little shotgun. Now let's do a little if statement, and we can just go down here and copy and paste this all the way to here. Okay, so we got this. Let's capture that area. So we're going to choose green, and I'm going to put a comma and press 2. So for 2 seconds we're going to see that area being captured. Then we're going to do a bound frustum, which is basically going to be the function that's going to take our thing. We're going to do a world bound frustum. Whoopsies, not world bound. Just a bound frustum is good enough. World bound frustum is good enough. We're just going to call it bf equals to new bound Frustum, and we're going to give it two things. So we're going to give it the bound Frustum, or the projection, and the model view. So projection is going to be our Frustum. Now model view is different from projection. It's actually the inverse. So what we're going to do is actually mathlib.inverse, and then inside here we're going to put view. Okay, then what we're also going to do is we're going to create a list of a node. Alright, we're just going to call it objects, I guess, equals to new. Just put these brackets, that's good enough. Then we're going to do a world.get intersection. We have intersection and visible. Right now we're just going to use intersection, save us some time. We're going to do, so it has a few of them. We're going to do this one. So bound Frustum, that's the bound. The bounds. The node type is going to be the node dot type dot let's just use object mesh static, and then we're also going to use the iCollection node. So for us, our iCollection is list. We're just going to use obj. So now it collected. So we're going to use a for each variable objects in obj. So what we're going to do is, for now, let's just do message. We're going to do these along with this, and then we're going to put a comma, and we're going to say objects.name. So this is just going to list all the names that got captured inside this little box. So why are we using object mesh static? So we're just trying to capture these three at the moment. They have a type of object mesh static. You have the ability to capture any type, so that means you can also capture the ground. You could also capture the sun or the camera if it hits it. But for now, let's just try to capture these three. So here we are. Let's just grab it, go in, click. It captured the trigger point and the thick, captured the thin, captured medium, captured thin and thick, and now it's not capturing anything. You could see the little greens in the middle of the air. That's showing you in the 2 seconds, and then the moment I touch it, we captured medium just on the corner. Okay? So we have a way to capture stuff that got hit by our shotgun. Alright, so that takes care of that. I think that's it for now. I'll probably find something else to do soon, but for now we got the shotgun with the intersection, we got a volume shotgun, and then on top of that we also got the movement pretty nicely now. Yeah, that's about it. I'll talk to you guys soon later, probably enemy AI or GUI. That would be fun. Alright, I'll see you guys next time. Goodbye.